for better Wi-Fi. Thanks and welcome back. If this is your first time joining, we hope you find this webinar informative and insightful, and we look forward to having you join future sessions. Before we get started, here are some housekeeping items. You're in listen-only mode, so your lines are muted. To submit a question, type your inquiry into the questions pane of the control panel. You may send in your questions at any time during the presentation, and our subject matter experts will address them during the Q&A session at the end. Today, Joel Crane, one of our technical solutions architects, has joined us to help field your questions. Today's topic is how to visualize a Wi-Fi network from a client's point of view. Brian Harkins, our training and enablement manager, joins us again to discuss this very important topic. Let's get started. Turning it over to you, Brian.
Thank you, ma'am. As you start planning your networks using a predictive design software, it's always good to keep in mind the devices for which you're actually designing the network. So if you design around the environment and the needs and capabilities of your clients, you'll always design a really good network. But seeing that in a prediction is not always easy. So in this webinar, we're going to look at how you can actually change the visualizations inside Ekahau Site Survey to look more like what a client would see than to see what the raw measured data would appear to be. So first, we're going to look at a standard visualization. We'll look at how that appears. We'll take a look at client perspectives versus the measured perspective. We'll look at how you change the visualization, and then I'll give us a brief demonstration of how you do that. And then we'll talk about the Ekahau solution for designing your networks and troubleshooting your networks, followed by some next steps to take after today's webinar. And we'll open up for questions as we do every week. First, the standard visualization, the default view is based on a measured value. And that's where you would have all of your APs on your map, and we would be able to predict where the signal strength would go through the walls and over distance, and any detected APs, if you wanted to show those on the map as well, as to where signal strength should be on the map, see that. But that's just a raw signal strength. And if you've ever really looked at received signal strength indicator value as determined from different clients, you'll know that they're not always the same. There's no industry standard for calculating the RSSI values. There should be, but there's not. Every chipset maker can determine how they want their chipset to interpret the information received, whether it's raw energy or data, and look at the signal strength and calculate that themselves. When you're looking at a standard visualization, you're looking at just the raw measured power of what's there, not necessarily how a client would see that, but more of how the raw signal is. And the same would hold true for access points. Access points calculate however they want to calculate based on the chipset they're using. So there's not really any standard way of determining that. You just have to look at the clients. And in our case, what we're going to look at is how to change the standard visualization from just those raw measured views to something more meaningful, something the client would see. So additional visualizations, client views. We have ways to look at the visualizations presented by the access points from the client side, because not all clients receive the same way. They're not going to respond the same way. So where you think you're getting, say, neg 65 dB signal for voice, the phone that you're trying to use may be calculating that as some other value. It could be higher, it could be lower. It just depends on the chipset used, not so much the environment and things, because what you hear is what you hear. How you interpret that, again, is up to the client device. So, a tablet or a laptop, they're going to detect things differently, report them differently. So will every other type of device that's out there, whether it's a wearable device from the Internet of Things or standard devices like point-of-sale devices, barcode scanners, things in the medical environment, machine-to-machine equipment. All of those devices are going to calculate what they hear differently, and they're going to make their data rate adjustments and whether they try to connect or not or try to roam or not based on what they hear and how they interpret it, more so than what we know to be there as a valid signal strength. So to begin changing the visualizations, if you're familiar with the Ekahau UI, in the bottom right of our adjustable legend, it's there, and you can see the different colors and see the signal strengths are there, and you can change that. You're very familiar with that. But to see the view from the client side is not a feature that's out in the open. It's a hidden feature because it's something you want to use sparingly. So to access that, you would hold down either your control or command key, and then click on the color legend bar, just like you're going to change the values that are there. But you click on the bar, and then you get a new drop down up top where you can see view as. The default view, as I mentioned before, is the measured raw values. So you're going to see view as measured by default, and there's a drop down, so you can obviously choose different things there. From the drop down, you could choose generic laptops, smartphones, tablets, voice over IP phones, barcode scanners, and we've kind of taken a generalization of what we know that the broad spectrum of that device type is going to see at that point. So it's closer than the measured value to what the clients would see, but it may not be exactly what your device sees. Now, if you're looking at a generic tablet, that's going to get you pretty close to most tablets. But like I said before, since every client device has a radio that's going to calculate the RSI values as that manufacturer wants them to do, it may not be exactly what you want it. So if you want something more exact, there's an edit icon in the upper right of that menu, and that will allow you to create your own custom device profiles. You start by giving it a name, and then you would select the technology you're going to use, A, B, G, N, AC. So you would choose what that client is capable of doing, which is more in line with what the clients would really be doing in the first place. There are still a lot of 2.4 only clients out there from the first generation of N, and believe it or not, there's still a lot of B and G stuff out there because the clients are working and there's no need to replace them if they're working well enough to do the job. So if you're trying to visualize for what an 802.11b client would see, that's what you would choose. If you're looking for what an AC client would see with different MIMO versus SISO characteristics, then you'd want to choose that. Then you're going to select the supported bandwidth. Newer access points can bond channels all the way out to 160 hertz wide, but that doesn't mean the client can do that. Many clients can only go to 40 megahertz wide. 802.11n only went to 40 megahertz in width. AC goes all the way to 160, but some of the clients don't go that wide to save battery life, because the wider the channel you're using, the more battery life you're going to take to transmit and use that client. So to save battery life on smaller devices, particularly wearables or Internet of Things devices, or even barcode scanners in some tablets still, they're going to have smaller bandwidths available in what they support. So you want to select what that particular client you're trying to model for actually supports, which means you're going to have to look into the specifications of that particular radio. Not necessarily the device, but the radio that's in that device. If the device says I can do X on their website, then it probably can, but you still have to go and look for that. It's usually not on the device itself. So you're going to have to go to the manufacturer's website or look at any of the documentation that's shipped with the device. Then you're going to pick the multiple input, multiple output variant that the device supports. That could be 1 by 1 by 1 all the way to 8 by 8 by 8. And that's one transmit, one receive, and one spatial stream for 1 by 1 by 1, which is what a lot of the smaller devices will be, because just like the supported bandwidth, the more efficient or larger size MIMO that you can use, the more battery life it's going to take to do that. So you're going to find a lot of things. Tablets are still largely 2 by 2 by 2 for newer ones. Older ones were 1 by 1 by 1. Laptops that are shipping could be 3 by 3 by 3 or 3 by 3 by 2, or even 2 by 2 by 2 still. So you need to look at what the particular client is. Now, we've modeled all the way out to 8 by 8 by 8 in case you do run across some fixed client, or maybe it's a meshing situation where you're dealing with access points that need to connect to each other, and they may support 8 by 8 by 8 MIMO. So you can model for that here. Then it gets into the tricky part. This is where you're really going to have to know that device. You're going to have to go into the specifications for the device. You're going to need to look at the requirements that manufacturer has and see what the offset needs to be. That's where you're going to look and see, this radio is going to receive, but it's not the same as receiving from an access point quality radio. It's not the same as the raw measured value. So you have to know what that device actually receives as. That may even involve, putting an AP up at a no transmit power and looking in the device and seeing what you're receiving there and know what the offset is. So you may have to figure that out yourself if it's not documented somewhere easy to find, or actually look at the chipset manufacturer's documentation more so than the documentation that's shipped with the device, because that's a value that most users will never understand or never need to know. So it's not something that is prominent on specification sheets usually. So you may have to go to the actual chipset vendor to find that out. And that offset is what makes doing this a lot trickier than it would sound initially. Because if on top you may think, hey, I just want to see what it looks like from this tablet or this wearable device. And you can set up a lot of that stuff just knowing generically what the device is capable of doing from the box that it's shipped in. But the offset is something that's a lot more involved, and it'll take you a little time to figure that out. So you want to make sure that you find the exact value from the radio chipset manufacturer or a specification sheet, or measure it yourself to make sure that you're getting a value that is really meaningful and useful to this process. But if you don't put in an offset here, you're not really modeling much differently than what you find for the raw measured values. Because you can model for the bandwidth and the MIMO when you're doing auto planner to place your APs, and you can choose the technology when you're doing that as well and get the raw values, which is what 99% of the people need to see anyway. But if you're in that 1% and you really need to see what's here, you've got to have that offset value configured properly, or else the visualizations are not going to be what you expected them to be. So now we'll look at a quick demonstration. I'm going to switch over to Ekahau Site Survey, and I'm going to add a map for us real quickly. And I'm just going to place a generic access point on the map, just one AP, and I'll widen that out a little bit. Just going to place one AP on the map, and this is the raw value of what we would see. I'll have to first draw in my areas with my area tool, so it confines it to just what we're doing inside the map here. And I'm not going to be exact with this because this is not about being able to draw the areas, but so about what the AP is doing. I'm going to change my visualization to signal strength up top. So now we're seeing what that one AP would be doing. I'm going to zoom in a little bit so we can see it better. We can see what that AP is doing, but that's just the measured value of what that AP would do through the walls and the air, and knowing the transmit power, knowing the frequencies we're using, and the free space path loss, the things that we're used to seeing. And again, this is what 99% of people are really going to need to see. But if you're in that 1%, you're going to need to hold down your controller command key, click on the adjustable legend in the bottom right, and you can see where that drop down is I told you about earlier. And I can hit the drop down and select any of those. Let's see what that would look like for a smartphone. Not a lot different, but let's see what it looks like for maybe a VoIP phone. You can see a little bit of change there, not a lot. Let me zoom in. Didn't change a whole lot. So let's look at making a custom device. So I'll click on the edit icon here on the right. And instead of using one from the drop down, I'm going to click the add button. And this will allow me to give it a name. It could be, any custom name you want to put in there. We can choose the technology, whether or not it's going to bond out to 160 or 40 or where we're going to put that. Let's say this is an older device. We'll put that at 40 megahertz. And 2x2x2 is pretty common for devices. Even some of the newer phones and things are shipping with 2x2. Some of the smaller devices are still 1x1. Most of them are. But 2x2 is not a bad choice there. And here's where I would have to go and research the offset for what my device will be doing. And just like any other visualization, if it's a dual band device or you're trying to look at dual band coverage, you need to plan for this in both bands, 2.4 and 5 gigahertz. So I can put in here something in 2.4, and I'll put in a value for 5 gigahertz as well. And then click close. And when I click close, my visualization should update for me, and I'll be able to see any real difference here. Now that one didn't change a lot, but it's a subtle difference of what we're looking for, because the radios are fairly close close to each other. And again, 99% of the people using the tool won't need to use this feature. But if you really need to get in, that subtle difference can mean the edge of, do I need to move an AP? Do I need to change its power settings? Do I need to add an AP? What's happening along the edge of this coverage? Because with our adjustable legend color down the bottom, remember we have want, and don't care values. Anything with the color is what I want. And that's going to be neg 67 or stronger according to the way I've got it set up. The gray area is going to be neg 67 to neg 80, still usable in Wi-Fi, but probably not going to give me the signal strengths and the data rates that I would want to have for my client devices to get the throughput that they need. And the white area is just, again, an area where I don't care. So let's add a second AP here. And we'll leave that where it is with visualization. So now I've got a second AP, and we'll see what that looks like for just a laptop. Let me change that from generic phone to generic laptop. That's not too different because, you know, laptops have got pretty good radios in them. Let's change those offsets a little more. Add in a new one, we'll call this number 2 just for quickness. Make that AC, and we'll do 80 megahertz wide channels, and maybe we'll make this one a 1 by 1 by 1, and we'll change the offset values to something like -2 for 2.4. We'll do -4 for 5 gigahertz. Close that out, and I'll change that to both. So, and 2.4, you can see we've got pretty good coverage out there everywhere, largely like you'd expect with 2.4. With 5, not so much. And looking at the custom visualization, let me change that to 2.4. You change that to measured, and it's, you know, what we expect to see. Switch it to any of these others, the one I just created, for example, and it changed slightly. We've got a slightly smaller coverage area in the signal strength that I'd required. If I'd required a stronger signal, say we move this to like a neg 65 for voice, that's naturally going to move in just even on the raw. But now we're looking more at what the voice requirements would be. Some voice vendors require neg 65 to say their phones will work. Some say neg 67. So it's a big difference, even though it's only 2 dB. So it's a big difference in the client and how they receive things too. So by changing just a little bit on the client side, it's going to model more accurately what your client devices should be able to receive and understand on their side in your predictive design. If we were just modeling for raw, like I said, 99%, that's fine. You're going to see you got good coverage everywhere. You've got the signal strength you want everywhere. But if you really want to see how that client's seeing it, it's useful in troubleshooting scenarios where you think you've got a good design, but you've got a finicky client that's having trouble. No other type of client's having issues, but this one client type is. You can model for that client, and maybe it was a good design in the past, but this new client is finicky, and you've got to change your design a little bit, which could mean tweaking the power settings on the APs, moving the APs around a little bit, or even adding APs. But being able to visualize from the client side is going to help you locate where you need to make that change in the live environment or in your prediction prior to deployment a lot better than just dealing with the raw signal strength would. So let's take a look back here now. Let's see. So from here, we have thousands of people that use Ekahau in terms of a company, over 1 million users worldwide using the product. That is a very advanced feature we just looked at. It's something that I would venture to say the majority of people using Ekahau don't know to do. Because again, it's a small opportunity where you really and truly need to adjust those. You'll be very careful adjusting those, because if you've adjusted your visualizations to one client, one very picky client, that could throw off the design for other clients, and you might be over deploying APs or creating additional problems to solve something for one small client if you're not careful with that. Next steps after today's webinar: schedule a one-on-one demo with one of our technical solutions architects, and request a free evaluation license. ekahau.com/evaluation will take you there, as well as that longer URL that's on the screen. And you'll get a copy you can play with for 14 days on your own. this point, I'd like to open up for questions. I believe we have Joel Crane on the line with us, as well as Jerry Ola. So if you want to throw some questions at us, we'll be glad to try to tackle those.
Yeah, sure. Thanks, Brian. So let's start off with this one. Will choosing wider channel support impact the resulting RSSI or SNR values?
It's not really going to affect the received signal strength values, but it will let you know the channel width at which the client has to operate. So if you have a client that is capable of that, then you can plan for that a little bit better. The APs, if the AP can do 160 megahertz wide channel, but your client can only do 40, that's not going to affect the AP at all, because the AP is going to be able to step down and do a 40 megahertz wide channel with no problem. But other clients that could do 160 meg channel could possibly have higher data rates because they can use more of what's there. So if you're just planning for 160 meg channel on your access points, that's not giving you a crystal clear visualization of what the clients are going to be able to do. So it doesn't hurt to adjust that down to 40 megahertz wide client for the visualization. It's not going to impact the functionality of the AP or the network, other than when the clients that use narrower channels when the contention, they're going to be using lower data rates. So if you have a lot of clients that are using narrower channels, even though you do have some that can use wider channels, when the client wins the contention for the you're going to be using lower data rates. Just like if you have a client that's really close to the AP and a client that's really far away from the AP using dynamic rate switching, the same thing would happen with the channel widths. When the wider channel client wins the contention, you get higher data rates. So the overall throughput is going to be a combination of what the wide clients can do and the narrow clients. It's just good to see the narrow clients perspective.
Great, thanks, Brian. We've got a number of questions about basically how to figure out what the offset is for a device in question. And Jerry, maybe you can chime in on this one as well. Maybe I'll just read some of these questions off really quick. Like here's one: Will Ekahau provide some client device profiles for more current devices like the Intel 8260 iPhones, for example? Another question I think is related is, does the manufacturer of radios, do they actually refer to an offset? Is there some way out there to find that? And finally, another question is, will Ekahau provide a device profile definition of popular devices, i.e. MacBook Pros, Surface Pros, iPhones? Any comments about those?
Yeah, so I wanted to, I guess kind of this wasn't necessarily going to be part of the presentation for today, but I think the timing worked out well for it. So Blake Croney, if you're not familiar with him, he's a wireless, guru, wireless professional in the industry here, and put together this great website actually, and just kind of debuted it, in the last couple of days here. So the timing worked out perfectly with this webinar. So I wanted to kind of promote that website here. So this is something independent of Ekahau. Blake's a good, he's one of the ECSE instructors for our training program, as well as, an avid Ekahau user. So he really liked that offset feature, and had those same kind of questions, and gets those kind of questions quite often of how do you determine those dB offsets. So he put together this RSSI compared.com website. I put the link in the chat there, and go to webinar as well. But yeah, there's already been quite a few. This is a user submission kind of system, so I would encourage you, if you've got some devices that aren't on the database here yet, or even if you are, even if the device is already on there, the more measurements we get, the more accuracy that we're going to have in determining what these proper offsets should be. So if we go to the page, you can see there's already 11 devices submitted, 147 measurements. If we go to the device data, you can start to see, where this really comes into play. So under here, we've got a bunch of different Apple devices, a couple other, Android devices, things like that under here. Let's go to like the Apple MacBook Pro 13, and you hit the view button here, and you're going to get all sorts of useful information about those measurements that were taken from that device, and what that kind of offset should be entered into Ekahau. So you can see at different distances on the 2.4 side, and then below that on the 5 gigahertz side, and what those measurements are. And here's kind of your max, mean, median, minimum dB offset values here that we can then use to input into that offset into Ekahau. So yeah, this I think will be a great database to be able to leverage for determining that kind of stuff, and also just having a central database where to refer to those kind of informations. He's got a great tutorial on here on how to add data to this site as well. So check that out. Walks through the whole kind of testing scenarios. That way we get good, consistent measurements input into here, and how to set up that kind of lab for this. But yeah, if you're not
this is reminiscent of the days before there was a tool. I'm sorry, Jerry. This is reminiscent of the days before there was a tool to plan with, and you had to measure every wall, and then people would put charts together. And now Blake's done the same thing for us with the offset. It actually has some of these measurements for us for very common devices, so we don't have to go out and measure every one that we have in the house.
Yeah, I put Blake's Twitter in the chat there as well. If you want to reach out to him, if you have any kind of feedback or anything for him on that, or find any kind of issues or anything, I'm sure he'd be more than happy to hear that.
Great. Thanks for talking about that for a minute, guys. So yeah, I think that should have knocked out a lot of your questions. Referring to the audience, that should have knocked out a lot of questions for you guys regarding, what the offset should look like. So I would definitely, use that with care and consideration, and be sure to test it thoroughly, before you start designing for it. But I think, when you look at that database, that should get better over time too. And as we get more and more data too, then that should just become even more and more reliable. So a couple questions that are slightly off topic that I can go ahead and answer really quick. One question from Tim is, how much different would coverage be from using a generic AP versus Meraki or Aruba? That's a good question, Tim. Basically, in Ekahau Site Survey, every single AP has a unique coverage pattern that we have put into the software. So all the coverage patterns for them are unique. So I would recommend choosing the model of AP that you're actually going to deploy when you are performing your virtual designs, to make sure that things are as accurate as possible. Really, there's just about no scenario in which I'd recommend using the generic profile. So. Another question from Jason, and since maybe we've got Jerry on the call here as one of our product guys, maybe I can throw you under the bus, Jerry. Jason says, are there any plans for data integration from the community source data?
Yeah, no plans today. Obviously, the RSSI compared website is, that's really the intentions there, is to have that community sourced data. But, yeah, we'll kind of see where things go. Obviously, this whole DB offset feature is very new to Ekahau, and it's kind of that hidden advanced feature today. So we'll kind of see where things progress. But, I think this is, as mobile devices and things like that continue to dominate, our Wi-Fi networks, and as that becomes more and more prevalent with IoT and everything else, I think these kind of things are going to be a bigger, and more critical factor in our designing and validation. So I can certainly see some emphasis being put on that.
Great, thanks, Jerry. Question from Bruce that, Brian, I think it'd be great if you could answer this one. Will the simulated client visualization work with SNR, or is it only RSSI?
That's just how the client would pick it up, and it's probably something that it depends on what you've got modeled in your predictive design. If you've actually done your physical walkthrough, so there is some noise, and Jerry, you may have to correct me on this since you're now on the dark side of PLM, but it depends on what you've got modeled there. So if you're only modeling predicted AP, no noise to model other than just the generic noise floor. If you have actual noise collected, that taken into accounting as well.
Yeah, and I think the bit that I would add to that is that SNR and RSSI are very, very closely linked. Basically SNR is just signal minus noise anyway, and so they're almost, not quite, but they're very, very close to being the same thing because they're so closely linked in that way. You change one and the other one changes right along with it. The only other variable is basically how much noise there is in the environment. Of course, that can change. The noise floor can go up and down, as well as a nearby device can start transmitting and can change the noise floor as well. So it's probably, in my opinion, probably not something that you have to worry about when you're adjusting the dB offset for client devices. So that's just my thoughts on it.
And that's not going to be a consistent influence.
Yeah,
unless you're in manufacturing or something, where you have noise there all the time, or maybe it's a very large UPS near a server room or something. It's always throwing noise out. But then you would find that with your physical survey and plan your channels around it anyway, hopefully.
One comment that someone in the audience made that I think is a pretty good one is maybe Mike Albano would add the dB offset next to his list. That's a great point. And that some of you may be familiar with client.mikealbano.com, which is an excellent resource for looking at which channels client devices support, as well as some other information about those clients. I definitely see how Blake's tool and Mike's tool would definitely go hand in hand. I would certainly want to have both of those up and running when I'm starting the process of designing my network and thinking about what client devices I need to support on my network. So that's a great observation.
I think so too. And keeping it near you would really, in this case, only be for those very few instances where you need to do this. This is truly a power user type function. And like I said, 90+% of the people will never need to do this. So it's great, I think, for people who are really advanced users for planning. And it's great for troubleshooting earlier if you have one finicky device type that is not performing, even though your plan is giving it the right signal strength.
Great. Well, I think that pretty much wraps up all the questions that we're going to be able to get to today. There's some other good questions here that don't quite pertain to the topic today. So actually, you know what? There is one more here from Bruce. I kind of like to check out before we go ahead and end the webinar today. Would channel widths impact impact noise and SNR? For example, would you see 3 dB less for 40 megahertz versus 20?
It would depend on where the noise is found. When you start bonding out, remember you're just adding more frequencies in for use. And if you're using a bonded channel, what would happen on the actual devices? If there's a lot of noise on a certain channel, some APs won't come back to that channel to use it. They'll just come back and check to see if it's clear again, and then they'll pick it up and start using it when it's clean. So it would affect you in a live environment. I don't believe the visualization is going to be impacted by that, though. I think we'll look at it as the noise always being there to plan for worst case scenario, where the AP would take into account, then not take it into account, and back and forth as it actually happened.
Perfect. Thanks, Brian. We've had a couple more questions asking about the websites that we've mentioned, so I'm just going to put those in the chat function really quick. The first is clients.mikealbano.com, and then the second is RSSIcompared.com. So those are the two websites that we've discussed today. Those are both excellent resources for client capabilities. Just in case you're not familiar with it, clients.mikealbano.com is all about looking at the capabilities of client devices in regards to like which channels they can Oh, Jerry I chatted them to us only. Yeah, thanks, Jerry, for fixing that. Clients.mikealbano refers to client capabilities, whereas RSSIcompared.com refers to dB offsets for different, basically receive sensitivity for different clients out there.
There's another good question from Taylor Brown about is Ekahau going to incorporate an elevation aspect so this can be used effectively in a mining environment? The answer to that is it's already in the tool. Let me show you my screen here real quick. Go back to me.
Well, technically not. Elevation is, but not the angle, right?
Right.
So I'll show you visualization
here.
And this is purely for planning. So for surveying, obviously it's going to survey at whatever elevation that you're taking those measurements from. But from a planning standpoint, we can adjust that visualization height.
So if we change that, it's again, it's a hidden feature. It's a more advanced feature. So just like accessing the client perspective visualizations, you're going to have to hold down your control or command key, but this time you're going to click the options button in the top of the UI, and it's in the bottom of the pop-up, the visualization height. So you can change that, and watch what happens to this map. If I change that to something much higher, I'll change that to maybe 40 feet or something really crazy. Let me get rid of that here. So you see, that's what it would look like from 40 feet. So if I were 40 feet above the normal visualization, this is where it would be. The standard visualization is for average client height. If somebody's walking around with something in their hands, or they're sitting at their desk on their laptop, because that's what's important, because that's where those devices are. But if you're looking at something like a large open area, like a stadium, or like the question actually said in a mine, then this visualization will let you know where the coverage would be. The AP height has not changed. The height of the mounting remained the same. This is just a visualization from the AP at that height. So I could go into the access points and raise their height and then visualize the same height as the AP if I needed to, in an environment that had a large open area where maybe a forklift was going up and down, or trucks were driving down into a mine or something. So that you'd have to change the mounting height of the AP in the prediction, as well as changing the visualization height to really get the best look at that. Is that the right way to say it, Jerry?
Yeah, it's adjusting the visualization height, not the AP. That's correct. Yeah, so the AP in this case, I believe, is still at 8 feet. So we're looking at visualizing the signal at 40 feet in the air. So we're actually above the access point now, visualizing the signal. So you can see there's still some signal even 40 feet up in the air above the AP.
Yeah, so that might even be good in, say, an atrium area, where it's not a mine or anything really strange. It's a regular building with an atrium. If I wanted to see the visualization of an AP that I've mounted in the atrium area, maybe for guest coverage, so I can see the coverage as it goes up through that opening, and get a good idea of what it's going to do to my access points and users on other floors near the atrium area.
And to follow up with that, Pablo had a great question that I think we pretty much just answered, but he says, in a warehouse where height is very important, how can I know the intensity of a signal at a specific height? Pablo, that's the feature right there that you'll want to use. So, for example, you might be mounting your APs, 30 feet off the ground, pointed downwards with directional antennas or something like that. And if you wanted to know, well, what's signal strength going to look like 20 feet in the air, then all you need to do is hold down that key when you click options, and then change the visualization height. Which key is it in Windows, Brian? I forget.
I believe it's the command key in Windows. I'm on a Mac, and it's control on a Mac, and I believe command on Windows.
Yeah, it should be, I believe, control on Windows, and it's actually the Alt Option key on Mac now.
I'm cheating. I'm actually boot camped on Mac, so I'm using Windows on a Mac. I'm probably going to hell for that, but that's what I'm doing. So you can.
So a couple more questions I'd like to tackle that just more about just kind of general design and RF design. One question is there a website or chart of different types of wall losses? You might find that there are some materials online that give you some generic wall types and what their losses are. But what we at Ekahau recommend doing is actually performing some measurements on a few walls in your environment to find out what the actual real world attenuation looks like in your environment, because every wall is a little bit different. In fact, some walls can be significantly different. When a dry wall is 2 dB in one building can be 4 dB in another building, depending on what's in the wall. So if you temporarily deploy an AP in that environment, usually about 15 feet away from the wall, or maybe even a little bit more, and then test the signal strength on the close side of the wall, and then test the signal strength on the far side of the wall, and then just subtract one of those numbers from the other, and there you go. Now you know how many dB of attenuation there is in that wall. So I recommend doing that on several walls in your environment. Basically, the more accurate data you give Ekahau Site Survey, the more accurate your predictive model is going to be, when everything is done. So that's what I recommend doing instead of relying on presets or something like that. Brian and Jerry, do you have any comments on that?
I'd just like to add to that. Once you do have that true measured value, because like Joel said, one drywall could be 3 dB and one could be 2.5. So that's a big difference. So once you have that inside ESS, you can click the little add button here next to our walls drop down, and you can make your own custom wall. So you can put in the dB loss, you can put in the thickness of the wall, the height from the floor to the ceiling, or the distance from the ceiling down. You can pick a custom color for it from our color palette, and then you would give it your own custom name. I did this for who was it? It was a pharmacy that had half-height counters near the register, and they stocked things on both sides of it, so it had a little different feel than the regular retail rack wall did. So we just measured the wall and made a custom wall with a custom height and everything, and you just save that in your project. And I recommend starting with a blank project, building all the walls that you think you need, and then every time you need to use those walls from building to building, just open that project and do a save as and save it as something different next time, so it's available for another use. But you can keep building, as many custom walls as you want. And I do recommend building your own custom wall rather than selecting something that's close to what you want and then editing it. You don't want to edit the default wall types. Just create your own, and pick your own colors. And if you need to reuse a color, you can change if you're not using the default type, you can change the default wall type to a different color, and then use the color you want on your own custom wall. So there's no confusion. If you're uncertain of a wall when you're doing your predictive design, if you have not gone on site for your physical survey yet and you're uncertain of what a wall is, we do have a wall type that's called unknown, and you can model that. And then when you're on site, you're going to look at it. So that's an odd color for an IT image. So you'll look at that and realize it's the unknown wall, and you'll measure. You can create your own wall type, and then just right-click on that desired wall and change the wall type at that point. So it's a good way to get you into a more customized design based on your particular environment.
And Curtis is asking, if there's a way to make the walls and device profiles persist between installs. Curtis, what I would recommend doing, and I do this fairly commonly or fairly often, is I'll actually open up a project file, and before I even add a map or anything like that, I'll go in and configure by device profiles and walls, and then I'll just save that project file off and kind of use that as my starting point for everything. So that's how I handle that. I hope that helps you out. So, all right, well, we're about at time here. Unfortunately, we weren't able to get to all of your questions. If you have any more questions, feel free to get in touch with us. Brian's going to put some of our contact information up on the screen right now. There it is. So yeah, feel free to get in touch with us with any of your specific questions. We're always more than happy to help out. And at this time, I'd like to go ahead and pass it back over to Nicole to close out the webinar.
Great. Thanks so much, guys. And thank you, everyone, for attending today's webinar. If you have any additional questions, like Joel said, just feel free to contact the team directly. You'll also receive a follow-up email within the next couple of days that has a link to view a recording of today's session. On behalf of the team here at Ekahau, thanks so much for joining, and have a great rest of your day.